This experimental setup is used to measure the heat transfer coefficient of the parallel flow and the counter flow heat exchanger. So this parallel flow and the counter flow both are arranged in a single setup. For that there is a two concentric pipe of 1 meter length and 9.7 copper tube at the center and the GI pipe of 12.5 mm. So these two pipes are insulated so that the heat transfer through the surface is prevented, and there is a geyser to supply the hot water to the copper pipe. So the geyser is heated by the electrical supply, and the hot water is flowing through the copper tube, and the cold water is supplied through the GI pipe, and there is a valve for both parallel flow and counter flow adjustment. So for parallel flow you have to operate the valve in such a way that the cold water is flowing through the pipe, concentric pipe, and hot water is also flowing through the same pipe. So these two flow are parallel. So it is a parallel flow heat exchanger, and the hot water is supplied comes out through the copper tube, and the cold water is again recirculated through the another pipe, another GI pipe, and you can measure the temperature at the inlet and the exit of the hot water pipe and the cold water pipe. For that, the thermocouples are connected at the inlet and the exit condition. So the hot water inlet and the cold water inlet and the hot water outlet and the cold water outlet are connected to the thermocouple. These thermocouples are connected to a 12-point channel thermal indicator. So by operating the knob at these points, you can measure the temperature of the hot water inlet, hot water outlet, and cold water inlet and cold water outlet. So by rotating this knob, you can take the readings of the temperature in this parallel flow condition. So you just switch the knob and you measure the temperature. So once you measure the temperature, then you have to measure the flow rate of the water. For that, you have to use a 1 liter beaker. So the cold water, the heat is transferred from the hot water to the cold water, so that the cold water is supplied to the GI pipe, and after this heat is gained, the cold water temperature increases and is supplied through the GI pipe. So you have to measure the 1 liter of cold water in a jar. So 1 liter jar, and you by using the stopwatch you measure the temperature so that you can calculate the mass flow rate. So once you know the mass flow rate and the temperature of the hot water and the cold water you can calculate the heat transfer coefficient by using appropriate formula. Then you rotate the valve and make the cold water which is passing through the GI pipe in the counter flow direction. For that, the hot water is supplying in the same direction, but the cold water direction is changed by operating the valve, so that it becomes counter flow heat exchanger. Then these thermocouples are mounted at the inlet and the exit of the hot water and the cold water pipe. So that thermocouples are connected again to the 12-point channel thermal indicator. So that temperature knobs by rotating the knob you can measure the temperature in the temperature indicator channel, and you note down the reading of the cold water inlet and the cold water outlet. Similarly, the hot water inlet and the hot water outlet. And by using the 1 liter beaker, again you measure the flow rate of the cold water. So by using the 1 liter jar and the stopwatch. So once you measure these temperatures, so appropriate formula, you substitute the values and find the heat transfer coefficient.